Hello friends, welcome again, and today in this session we will discuss plane figures, simple cases of plane figure. Now plane figure is a two-dimensional object. It can be a triangle like this, it can be a rectangle, it can be pentagon, hexagon, any shape, but it is a lamina. It does not have any thickness. And therefore you have edges, or you can say you have edges and corners of a plate. Plate can take any position in space, but the simplest position is when it is parallel to either horizontal plane or parallel to vertical plane. So if you take a case 1, let's say case 1, figure parallel to HP, and no other condition is given. A plate, it can be, as I told you, it can be a rectangle also, it can be a triangle also, and let us say a plate parallel to horizontal plane. So it is perpendicular to vertical plane, and therefore this edge is perpendicular to vertical plane, this edge is horizontal, this edge is parallel to vertical plane in this position. Now you can take any position, you can take this position also, you can take this position also. Now let us take a very simple case when plate is parallel to horizontal plane. ABCD is a rectangular plate which is placed in the horizontal plane, and when it is placed in the horizontal plane, elevation of each of these points will be on the ground line. So elevation of A and B will be A and B, and because BC is perpendicular to ground line, and therefore elevation of these two points C and D will also be perpendicular, and because CD is also taken parallel, or AD is perpendicular to ground line, and therefore the elevation of A and D will coincide with ground line, elevation of B and C will coincide with ground line. So the plan will be the true shape. The plan of the plate will be the true shape because it is in the horizontal plane, and therefore each edge will be true length and elevation will be a line. Elevation will be a line in the ground line. Similarly, if you take a plate, let's say a triangular plate in the vertical plane, A, B, C. If you place a triangular plate in the vertical plane, then you can measure each length here in the vertical plane. So there is a true shape of the plate, and its plan will lie on the ground line. A, B, and C. ABC is on the ground line, and that is the plan. That is the simplest case. Plate either in HP or in BP. No other condition is given. In case 2, we add one condition to this case. The plate is still parallel to HP, or plate is in HP, but one edge inclined to vertical plane. Inclined to vertical plane. Now, in this position, we took the plate like this. Now you take the plate like this, so that one edge of the plate, let us say AB, is inclined to vertical plane. And because the plate is parallel to HP, plate is kept in the HP, and therefore the true length will be the plan, and this angle with the vertical plane will be shown in the plan. So now the plan, you satisfy the condition of angle phi and draw the plate, true shape of the plate in the vertical plane. A, B, C and D. Size of the plate is known. Angle phi is also known. Angle made by the edge AB. It can be BC also. And its plan is the true shape. Elevation will be on the ground line because the plate is in the horizontal plane. B dash, C dash, A dash and B dash. This is the elevation, a line. Why line? Because the plate is perpendicular to vertical plane. Therefore, this will be a line. If you are keeping this plate in the horizontal plane, this elevation will be on the ground line. If you keep it parallel to horizontal plane, then this elevation can be at some point here. It can be here also. A dash, D dash, D dash, A dash, C dash and B dash. And this is the height of the plate. The height of the plate above horizontal plane. Similarly, you can keep the plate in vertical plane or parallel to vertical plane and one edge inclined to horizontal plane. This is also part of case 2. Same thing that you first satisfy condition of theta, edge. Angle made by the edge of the plate will be theta phi, angle made by the plate will be alpha beta. So, and take AB here, edge of the plate, which is making angle with the vertical plane, and complete the figure. ABC, it can be triangle, it can be pentagon also, it can be square also. But we are keeping this plate in the vertical plane satisfying the condition of theta, that one edge AB is inclined to horizontal plane. And its elevation is a triangle, the true shape, the plan will be on the ground, a line, ABC. This will be the plan. Because when you place the plate in vertical plane like this or like this edge is inclined to horizontal plane, but the complete plan will be a line on the ground line. These are two simple cases. Case 3 is or we plate inclined to horizontal plane or vertical plane, but it is inclined to only one of the reference plane, either horizontal plane or vertical plane. So let us take a rectangular plate or a triangular plate which is inclined at angle alpha with horizontal plane. Now this is the situation. You take a plate here, which is inclined to horizontal plane at angle alpha. It's similar to inclined plane. It's a part of inclined plane. So to draw its projection, this plate is still perpendicular to vertical plane because it is only inclined to horizontal plane. And if you consider this like this, that you have a inclined plane. Within this inclined plane you have this plate. Within this inclined plane you have this plate. So to draw its projection, what we do, you first take the horizontal plane like this. The first case, when the plate is in horizontal plane. Okay, so first you assume that the plate is in the horizontal plane. A, B, C, D, so that its elevation is on the ground line. Now you rotate this plate, you rotate the plane rather containing this plate, so that now it makes angle alpha with the horizontal plane. So you take inclined plane here. You take inclined plane here and angle alpha. And this plate is in the inclined plane now. So when you rotate this plane, each point in the elevation will also rotate about this point T. About this point T. You see here rotation of the plate, and therefore this is the vertical trace and horizontal trace of inclined plane making angle alpha, and the plate will rotate so that elevation of each point will rotate. So taking T as center and this as radius, you draw the arc here. Rotate each point about T, each elevation point about T. But when you are rotating this plate from this position to this position, we are not changing the distances of their plan. Distance of each point here from the vertical plane remains same, and therefore each point here will be the same distance from the vertical plane. So A will move parallel to ground line. Similarly, B will also move parallel to ground line. B will move to this position, and C will be here. So your plate, the projection of this plate is now not the rectangle, not the true shape, but a smaller rectangle. This one. And let us say this is A1, B1, C1, D1. A1 dash, B1 dash, B1 dash, C1. So this is the elevation, a line, and this is the plan. A small rectangle, a smaller rectangle. Satisfying the condition of alpha, plate is now in the inclined plane making angle alpha with the horizontal plane. Similarly, you can take the case when the plane is inclined to vertical plane like this, that you have, rather than taking IP, you can take ABB now. So place first the plate in vertical plane and then project it here on the ground line, that is the plan will be a line here, and then you take an ABB at angle beta. ABB. And rotate each point in the plan about this T. Each point in the plan about T. And then project these points in the vertical plane for their new elevation. So C will be here, C1 dash. B will be, each point moves parallel to ground line, B1 dash. And A will be here, A1 dash. That is the new shape. This is the new shape of the plate, or you can say projection of the plate when it is inclined to vertical plane. Right. Now in the same case, you can add one more condition, and that would be case 4. Case 4 is when the plate is inclined to HP at angle alpha and one edge inclined to vertical plane. One edge inclined to vertical plane. That was a simple case. This is also a simple case that here in this case what we have done, when you place this rectangular plane A, B, C, D in the horizontal plane, we took this A, B parallel to ground line. Now you can satisfy this condition of phi, that this AB makes angle phi with the vertical plane. So let us redraw this figure here. That this is angle phi, and let us say edge AB makes this angle. So take AB on this line, then a true length, plate is still in the horizontal plane as a first position, initial position, and complete the rectangle given dimension. Now this position A, B, C, D is now this position. It satisfies condition of phi, that one edge AB is inclined to vertical plane. Get the projection on ground line. So this is D dash, A dash, C dash, and D dash. Now the next step is same, that because the plate is inclined to horizontal plane, so take IP here. Take an IP anywhere. Take an IP at angle alpha. Alpha is given. Rotate each point in the elevation. Rotate each point about T. And then get their new plan. Get the plan. This is the point D. This is the point A. This is the point C. And this is the point B. Remember, each plan will move parallel to ground line. And join them by straight line, you get A, B, C, D. This will be a parallel. It will not be a true shape of the plate. It will be a parabola. And elevation will be a line because the plate is, let us say, E1 dash, A1 dash, C1 dash, and B1 dash. Because plate is perpendicular. Plate is perpendicular to vertical plane. So, but in this position, after rotation, so it will be a line. Similarly, you can take a case when the plate is inclined to VP at angle beta and one edge inclined to HP at angle theta. Same case. Here, instead of putting this line AC parallel to ground line, you can place it making angle theta with the ground line, satisfying the first condition of the edge making angle with the horizontal plane. And the remaining procedure is same. Now, it can also be like this, that the plate is inclined. It can also be like this, that plate is inclined to HP and one edge inclined to HP. This angle is alpha and this angle is theta. This can also be a problem, that the plate makes angle alpha horizontal plane and one edge of the plate is also inclined to horizontal plane. Now, this can be solved if you recall the projection of lines. How do we draw projection of a line? Whenever a line makes angle theta with the horizontal plane, let me draw. This is a line which is inclined to both the reference planes. And in my session I told you that this is L sin theta, this is L sin phi, this is L cos phi, and this is L cos theta. Whenever a line makes angle theta with the horizontal plane, there is always a height difference between the two ends that is equal to L sin theta. L is the true length. Now here, if the edge is inclined to horizontal plane, plate is inclined to horizontal plane, the final projection will be of this type, that the elevation will be on the vertical trace and plan will be a parallelogram or maybe a triangle if it is a triangular plate, but the final elevation will be on the vertical trace at angle alpha. Now, if AP is inclined to HP, then this difference must be equal to L sin theta. L is known because you know the plate size, theta is given, and therefore in the final elevation, the elevation difference between A and B must be equal to L sin theta. So if you are able to satisfy that condition, because here phi is not known, if you are able to satisfy this condition in the elevation, then edge will make angle theta with the horizontal plane. So let us do that first. Let us take ground line, a vertical trace of an inclined plane which makes angle alpha. Alpha is given, and take any 2 points here at a height difference of L sin theta. How do you determine L sin theta? Draw a triangle. Don't use calculator. Draw a triangle at angle theta. This is L, so this is L sin theta. Measure it. This is L sin theta. So let us say this point is final A1 dash, and this is B1 dash. Right? Now, how do we place this plate in the horizontal plane? So rotate these points about P and bring them on the ground line. Just reverse of this, like this. And this is A dash and B dash. Now this line AB is parallel to horizontal plane, but it is in such a position that when you rotate the plate making angle alpha, this edge will maintain a height difference of L sin theta. So projector from A dash and B dash, take A anywhere on this line A and complete the true shape of the plate ABC. Now we are here in this position, that we place the plate in horizontal plane ABCD. But this plate is placed in such a position that when you bring it on the inclined plane, this edge will make angle theta with the horizontal plane. Remaining procedure is same as here. What is that? We draw projection of each point, rotate them about T, and then get their plan. Get their plan. This is C. And this is B. And that is the final projection. A, B, C, D. And this is the final elevation. Satisfying both conditions, because now the elevation difference between A and B is L sin theta, which you took in the first step, and because elevation lies on vertical trace and therefore this plate will make angle alpha with the horizontal plane. Similarly, you can take the case the plate is inclined to vertical plane at angle beta, and one edge is inclined to vertical plane at angle phi. Very similar to our first case. Rather than putting the plate on VP first and then bringing it on the AVP, satisfy the condition of L sin phi. Satisfy the condition of L sin phi in the plan. So, take an AVP at angle beta, take 2 points here at a plan difference of L sin phi. Let us say this is A, this is B. Rotate them about T, and then you draw the true length of the edge in B. Take A anywhere, okay, and complete the figure. Complete the figure. Let us say C. Okay, A, B, C. Go back from C, rotate it, and you get a new point. That is C dash. From B, you get a point here, B dash. From A, you get a point here, A dash. And this will be the final plan satisfying both the conditions. This is the plan. A, B, C is a line on the horizontal trace of AVP, and elevation A dash, B dash, C dash is a smaller triangle. So friends, thank you very much for watching this video. In this video we have learned how to draw projection of a plane figure under its simple positions. And simple positions, I told you, it can be parallel to one plane or inclined to one plane, one reference plane. In the next session, we will discuss the plane figures inclined to both the reference planes.